A very good morning to all of you. Please check if I'm audible. All right. I think some of you are not able to join, right? All right. So last class, we have just started with the LCM HCF concept. So there we have just discussed LCM is greater than HCF. That is the first thing we have discussed. We understood the meaning of LCM and HCF. The meaning was write the multiples of all the numbers, whichever multiple is common and least also, that is your LCM. And similarly, if we have to see the highest common factor, we have to write the factors of all the numbers, whichever is common factor and highest, that is your highest common factor. Okay, one more thing. Most of the question will be somehow related with this statement. Now, how we will solve it, that depends. That we'll see. But actually, the concept behind is this. I can take, instead of xy, I can take x, y, z also. Three numbers I'm saying. So carefully see, if a number is divisible by x, y, z, p, q, r, a, b, c, whatever number of numbers are there, it doesn't matter. If the number is divisible by so many numbers which are present, the number will be divisible by the LCM of all the numbers also. Here I've written two numbers, x and y, but I'm saying if there are 20 numbers also, their LCM calculate, the number will be divisible by LCM also. What I'm trying to say is, let's see with an example. Okay, see please. A number is divisible by both 12 and 16. Only two numbers. Divisible by 12, divisible by 60. So what can I say with 100% surety? 100% surety is the number is divisible by these two, so number will be divisible by their LCM also. So what is given, carefully see, the given information is this. There is a number which I don't know. It is divisible by 12. It is divisible by 16. It is given. So what I can say from this information is number is divisible by LCM also. LCM of these two. What is the LCM of these two? How much? Think multiples, whichever is common, that is your answer. So which multiple is common? Quick answer. 48. 12 into 4, 16 into 3. LCM is 48. So for 48, there is 100% guarantee. 100% guarantee. Whatever number you tell, which satisfies this, will satisfy this also, 100% surety. Okay. Now you might say, sir, why not 96? Why not 72? Why not 32, sir? You might ask. So please ask your doubts based on this. I will clear it out. What doubts do you have? For 48, 100% surety I'm giving. For other numbers which are not factors of 48, don't tell me below 48. Okay, don't tell me factors of 48. Tell me something else. 48 is LCM. Tell me any number which satisfies these two. Any number. Any number which is divisible by 12, divisible by 60. You can tell any number. Okay, 96. Okay. So 96 is divisible by 12, divisible by 16, yes or not? Is it the right number we have taken? Okay, 144 also. Okay, 144 also. Okay, 144 also. Now you might ask, sir, Okay, 96 is divisible by 48, sir. Okay, 100% guaranteed. Okay, yes, correct. Now you will ask, sir, one more thing. Sir, 96 is divisible by 96. Sir, why you are not giving guarantee for 96? Why just 48? You might ask, sir, 144 is divisible by 72. So, sir, why you are not giving guarantee for 72? So, please carefully answer. 144, okay, this number, only this number is divisible by 72. Okay, for this particular case, divisible by 72. Is this number divisible by 72? 96, is it divisible by 72? No. So, my dear, this is just one coincidence. Not all number will be divisible by 72. Only this number is. So that's why I'm saying 100% guarantee is for 48. 100% guarantee is not for this. 100% guarantee is not for this. Some percentage is there, but not 100%. So 100% for this, but it is also possible. Now you might ask, sir, please give us one example in which it is not divisible by 96 or not divisible by 72, like that. So carefully see, please. Can I take the number as 48? Is this number satisfying the condition given? Yes. Okay. Now 48 is divisible by 48. It will be, because I'm giving you guarantee, it will be. 48, is it divisible by 72? Is it? No. 48, is it divisible by 96? No. So that is what I was saying, that somewhere you might get divisibility by 96. Somewhere you might get divisibility by 72. Somewhere you might get divisibility by 80. But my dear, we are looking for the guarantee. Guarantees for 48. Why guarantee for 48 only? Because it is the LCM, that is the concept. So 100% guarantee is for LCM, not anything greater, not anything else. Understood? 48 guaranteed, rest all possible, not guaranteed. Okay. All right. Now don't say, sir, LCM of 48, sir. So number is divisible by 4 also. Sir, why you are not giving guarantee for 4? My dear, we are looking for the greatest number for which we can give guarantee. The greatest is this. Other than this, if 48 is guaranteed, all the factors of 48 also are guaranteed. All factors of 48. 100% guarantee. If 48 is guaranteed, all the factors of 48 like 2, 6, 4, 3, 12, all these are also guaranteed. Okay. Is this point clear? Please confirm this. All right. All right. See one definition, extremely important. For example, if I go for 6, so what was the divisibility rule of 6? Which two numbers? You will say, sir, 3 and 2. For 12, which two numbers? 4 and 3. Okay, for 72, which two numbers? 9 and 8. Okay, for 45, which two numbers? 45, 9 and 5. Okay, For if I say 90, which two numbers? Which two numbers? 9 and 10. Okay. All these pair of numbers, whatever you have said, that means 4 and 3, 9 and 5, 9 and 10. All these numbers, do they have any common factor? Please tell me that. Do they have any common factor? Yes, no. No. 9 and 10, no common factor. 4 and 3, no common factor. 2 and 3, no common factor. So my dear, when we discuss divisibility rules, we have discussed with the set of numbers which do not have anything common. Those set of numbers are called as coprimes. So coprime, very simple definition. Don't think it is related with prime number concept. No. Only one condition is there, that whatever numbers you are taking, there should be no common factor. That is one condition. Okay. So numbers do not have any common factor. This is the condition. If there is no common factor, you can say coprime. And if I take two numbers, that means coprime pair. Okay. 10 and 11, coprime. Because nothing is common. Now don't say, sir, 1 is common factor. My dear, 1 is always common. This is also coprime. 16 and 3, no common factor. 12 and 5, no common factor. So when we have no common factor, then we say the set of numbers are coprimes. Okay, don't say coprime, coprimes. Whenever we see numbers, set of numbers like this, the LCM will be equal to product. What I mean to say is, see please, LCM of 10 and 11, because they are coprimes, will be equal to 10 into 11. If I say LCM of 9 and 17, so 9 and 17, the LCM will be 9 into 17 because they are coprimes. LCM of 16 and 3 will be 16 into 3. Okay, and so on. So this is what I'm saying, LCM for coprime, not anywhere else, coprime. LCM for coprime is equal to product. So when you see anywhere numbers like nothing is common, just take the product, you will get your LCM. So LCM is product, product is LCM. Okay, for other cases, that means where something is common, we will take it outside. Okay, there we'll see. All right, so based on this, I've just created two questions. You should know that. Okay, please answer what is the LCM of this? LCM, how much? Nothing is common, so just take the product, don't overthink. So LCM equals to 13 into 11 because it is coprime. This will give you 143. Okay. Now next. There is one thing. Okay, LCM they are asking. Okay. This question, see please. Numbers are not given, but still they are asking their LCM. Product of numbers is given. What will you say? What is LCM? Whatever is product, that is your LCM, because numbers are coprime. So LCM equal to product whenever the numbers are coprime. So if product is given 903, so that product is your LCM also. So LCM is 903. Okay. So this is how you have to identify in certain cases wherever coprimes are there. All right. Okay. So three numbers I have taken. They are not co-primes because something is common between them. So now I cannot say the LCM is equal to this. I cannot say now because common factors are there. In such cases, when common factors are there, you have to take the common factors outside until we see the co-prime set of numbers. What I'm trying to say is, see please. We will use the tabular method because numbers are little bit bigger. So 6, 72 and 120. Okay. All of you know prime numbers. What are prime numbers? All of you know this? Okay. A prime number is a number which is divisible by 1 and itself, and it should have two factors, exactly two. Okay. This is tabular method. As per the tabular method, you have to take prime numbers to be exact. But what I'm saying is, there is no foundation. You take only prime numbers, because if you keep on taking prime numbers, it will become very lengthy. So what I'm saying is, please carefully listen. If you take prime number, don't think anything. If you take something else, then the number, if it is not prime, then the number should cancel out this, this, and this. So tell me a number, any number, which cancels out all of them. All of them. Don't say prime. Try to say the highest, which divides all of them completely. Okay, 6. So 6 is common. So take 6 outside. Why you are taking 6? It is not prime. Actually, you should take prime numbers. But still, why you are taking is because 6 will cancel out this, this, and this all. That's why you are taking. All right. Now carefully answer. 6 into 1. 6 into 12. 6 into 20. All right. This is 1. That means this is done. Now answer next one. What is common to these two? Try to say the highest. Highest. 1 means don't think. 4. Okay, 4. So why you are taking 4? Because 4 will cancel out this and this. 1 means it is done. Don't say 4 does not divide this. So 4 into 3, 4 into 5. Okay, now see please. Anything which is common factor now inside the table, not outside. Inside the table. Anything which is common. No. So again, if nothing is common, you will multiply, you will get your LCM. If there is common factor, you will take it outside, then you will multiply. So now this complete multiplication is your LCM. Understood the concept? Carefully answer. If common factor, take it outside, then multiply. If there is no common factor, just multiply. Simple concept. Okay. Now, okay, 5, 3, 15, 466, 360. So 360 is your LCM. Okay, now suppose from the same thing, whatever we have done, we have to identify the highest common factor also. Okay, so tell me please, whatever you have done, carefully answer. What was the number which has cancelled all these numbers present? All the numbers. Will you say 4 cancelled all of them? Will you say? Will you say 4 cancelled all these numbers present inside the table? Will you say 4? No. So 4 will not be counted. 6 is the number which has cancelled all of them. That's why 6 is your highest common factor. Is this point clear? Please carefully confirm. Carefully see this calculation. Highest common factor is 6 because 6 cancels all. Okay. So this is the tabular method. We apply the tabular method wherever the numbers are having many factors. The numbers are, I can say, a little bit bigger also. For example, it is 6, 12, 18. Then I will not apply this because numbers are small. I know the table of 6, 12 and 18 also. So I will not think this way. I will think directly. If suppose, see the other way. So one way is tabular method, which we have just seen. Okay, one way is if values are very small, numbers are very small like this. So we know the tables of these numbers. So we will directly think multiples and whatever is common multiple or common factor, that is our answer. But yes, if numbers are small, if the numbers are given in prime factorization form, then what we have to do is carefully see please. Let's take one example for that. What is prime factorization form? You will see. This is prime factorization form. The numbers are 2 square, 3 square, and 7 square. Why this is called as, this is also a number, right? But number is not given like 143, 2000, 2015. Number is given in this form. This form, my dear, is called as prime factorization form because I can see prime numbers. That's why. So prime numbers written with powers, that is called as prime factorization form. Whenever numbers are given like this, actually it is more simpler. Write both the numbers, one below the other. Okay, 7 power 1. Okay, these are the two numbers. In case of 3 number, 4 number, 5 numbers, doesn't matter. Logic is same. The LCM and HCF. How to calculate is, just answer what is greater, LCM or HCF? LCM or HCF? LCM is greater. Okay, so concept will be defined just by this. LCM is greater, so take greater powers for LCM. HCF is lower, so take lower powers for HCF. Higher powers for LCM because that is higher, lower powers for HCF because that is lower. What I'm trying to say is this. 2 square 2 power 1. Higher power is 2 square. Lower power is 2 power 1. 3 square 3 power 4. Higher power is 3 power 4. Lower power is 3 square. So higher power, write with LCM, lower power, write with HCF. This is what you have to do. Similarly, for 7 also, 7 square is higher power, 7 power 1 is lower power. So this is how you have to write. Now, most of the cases, they will not ask you the LCM because LCM will come out to be a little bit higher value. So this calculation is bit more calculative. That's why they will ask you this. And this will give you 9, 763 into 2, 126. 126 is your answer. So very simple concept. LCM is greater. So take greater powers. HCF is lower as compared to LCM. So lower value, lower powers. Just one more case I'm taking. For example, suppose all right. Think please. 5 and 11. Until now, what we have seen is 2 power, 2 power, 3 power, 3 power, 7 power, 7 power. But now I can see 5 only in the first number. I can see 11 only in the second number. In that case, how you have to think is this way. So my dear, just carefully answer. Can I think this? This is 5. So can I say this is 5 power 0? If 5 is not present, so can I say 5 power 0 is present? Yes. Similarly, if 11 is present there, 11 is not present here, so can I say 11 power 0 is present? 11 power 0 is 1 and 1 means nothing. So 11 power 0 is present. You cannot see, but it is present. So now answer, what is greater power? Greater power is 11 and lower power is 11 power 0. Okay, 5 power 1, 5 power 0. Higher power is 5 power 1, lower power is 5 power 0. This is how you will have to think if numbers are like this. Understood both, all of you? Yes. So higher powers for LCM, lower powers for HCF. That is the concept. Okay. Now next. Okay. If numbers are decimal numbers, then how we have to do it? Just one more case. First, you will write the numbers 1.08, 0.36 and 0.9. After this, there are various ways to explain, but think it this way. Because these are decimal numbers, so you have to think that where is the decimal? Where? So decimal is present after one place. Decimal is present after two place. Decimal is present after two place. Now, decimal should be present at the same place. That means if it is after two place, there also after two place, there also after two place. So you have to create, you have to do some modifications so that decimal is present after same number of place. Now see please. If I put 1 0, did I do anything logically wrong? Can I do this or can I not? Can I do this? 0.9 and 0.90, are they same or different? Same. Okay, but why I have done this? Because if I put 1 0, the decimal seems to be present at the same place, yes or not? Same place. Okay, this is why I am doing. Once you have done this, then you will remove the decimal, remove the decimal, remove the decimal. Okay, just for 30 seconds, I have removed the decimal. Okay, so first thing, decimal should be present at the same place. After that, remove the decimal. Now answer, what is the greatest common divisor or highest common factor of this? Quick calculation. 108, 36 and 090 means 90. What number cancels out all of them? That is your HCF. Okay, 9. So 9 into 12, 9 into 4, 9 into 10. Anything else which is common to all? Anything else? Lavanya, adding 0, if it has changed the value, it's very serious situation for you. Anything common? Yes, 2 is common. 2. So 2 into 6, 2 into 2 and 2 into 5. anything common to all. I'm not calculating LCM. I'm calculating HCF. That's why I'm saying common to all. Anything common to all? No. So this is your HCF. So your HCF is how much? 18. All right. HCF is now 18. Without decimal, we have calculated. Now, what did I say? Just for 30 seconds, remove the decimal. 30 seconds over. Please put the decimal back. Once you put the decimal back, please carefully answer. If you put the decimal back, you will put it after two place, after two place, after two place, after two place. Yes or not? Yes. So this is your answer. So, but one thing you have to do, we don't have to just remove the decimal. We have to remove the decimal after maintaining the symmetry. The decimal is present after two place, after two place, after two place. That's why we have removed it. Understood or not? Carefully see, please. Very simple process. Because 9 cancels all these numbers, 2 cancels all these numbers. That's why 18 is the highest common factor, because 18 will cancel out all. Okay, 18 will cancel out all the numbers. 18 into how much? 18 into 6. Okay, 18 into 2, 18 into 5. 18 cancels all of them. That's why 18 is HCF. Don't say, sir, 2. One more time, 2. My dear, 2 cancels only these two. 2 does not cancel out this. I would think this part if it is LCM calculation, not with HCF. Okay. You will not take it. HCF means highest common factor. So common to all. Okay. These two are common to all. That's why these two are common factors. Okay. Common to all. Please remember that. Yes, both are same. If they ask LCM, I will take out 2 also common, which is, I will take out 2 common from these two. Okay. In HCF, it should be common to all. In LCM, anywhere if it is common, we'll take it outside. In LCM, it is not mandatory that it should be common to all. Okay. All right. Okay. Please solve this question. The highest common factor of any three numbers, any three. If LCM is 540, the LCM is 5.40 if you have calculated. Okay. So any three. Now which three numbers you will think, right? So take any numbers, whichever you want. So if I take 1, 2, 3, or if I take 2, 3, 4, or if I take 11, 12, 13, anything you take. So any three consecutive numbers, what is common factor? Please answer. Common to all. 1. What is common to all? 1. What is common to all? 1. So whether you take any 2 consecutive or any 3 or any 4 or any 5, always the highest common factor is 1. Okay, HCF is 1. Okay, so please remember this. Any numbers which are consecutive in nature, HCF is always 1. Always. Not for 3 numbers, for 2 numbers, 3 numbers, 4 numbers, 5 numbers, 100 numbers, the HCF is going to be 1. One more question. 24, 36, 40. Please calculate LCM of the 3 numbers. Start, please. LCM. LCM of these 3, not HCF. If you are saying 12 as HCF, that also is wrong. LCM, not HCF. Okay, in the starting, if possible, try to think those numbers which cancels all of them. Okay. So tell me which number cancels all of them? 4. Okay, 4. So 4 into 6, 4 into 9, 4 into 10. All right. Now next. What do you think is common now? What do you think? 3. Okay, 3. 3 is common to these two. Why I am taking 3? 3 is not cancelling all of them. So why 3? 3 does not cancel all of them. So why 3? LCM. If HCF, I will not take 3 because it is common to 2, not this one. Okay. Should I take, if I suppose say HCF, will I take 2? 2 is common to these two. Will I take 2 if I calculate HCF? No. For HCF, we have to see common to all. For LCM, we have to see common, not to all. To all or anywhere if it is common, we have to see. Okay, so it is not HCF calculation, it is LCM. So you have to see common. Anywhere if it is common, take it outside. So I'm taking now 3 outside. 3 into 2, 3 into 3. Anything common now? 2 is common. Okay, so 2 is common. 2 into 1, 2 into 5. Okay, anything common now? No. So now just take the product now. You will get your LCM. So LCM equal to 2 into 3 into 5, 4, sorry, into 1 into 3 into 5. Okay, this will give you 5, 3, 15, 460, 60 into 6, 360. So 360 is your LCM. All right. So this is how one by one, we have to take whatever is common, we have to take it outside. But please remember the very important aspect. The very important aspect is when you take a number which is not prime, you have to be cautious. Actually, we have to take prime number. So there is no, if you take 3, you can never be wrong. It is prime number. If you take 2, you can never be wrong because it is prime number. But when you take some number which is not prime, then you have to be cautious. So why we have taken 4? For LCM, HCF, whatever it is, why we have taken 4? 4 is not a prime number, but still why we have taken? Because it cancels all of them. So a non-prime number you will take if it cancels all of them, otherwise don't. Understood this point? If it cancels all of them, then you will take a number other than prime, otherwise don't take. For example, just one hint I am giving you. If you do this mistake, your answer will come out as wrong. Suppose you have taken 12. Suppose. So what you will do is 12 into 2 and 12 into 3. Now 12 is not a prime number. 12 is not cancelling all of them. But yes, 12 is common to these two. So now you have done the mistake. Okay. So please don't do this. Is this point clear that why we will not take 12? Because 12 is not a prime number. It does not cancel 40. Okay. My dear, if you start with 2, the number of steps will increase. Okay. Yes, 8 you can, no, not 8. You cannot take 8. So this is wrong. Why this is wrong? Because 12 does not cancel. 12 does not cancel 40. That's why it is wrong. Suppose if I say one student is saying 8. If I take 8, so 8 into 3, 8 will not cancel out this, 8 into 5. So you have taken a number which is not prime and it is not cancelling all of them also. So that's why the number you have taken will not give you the right answer. So 8 does not cancel 36. That's why you cannot take it. Okay. Now, if you proceed further, you will get the wrong answer. Understood the point? Please carefully see. Yes, 4 you can take. 4 cancels all of them. Okay. 4 you can take. 8 you cannot take. 12 you cannot take. 20 you cannot take. Okay. Any number which cancels all of them, prime or not prime, doesn't matter, you can take. Prime number anywhere you can take. No issues. Okay. So for non-prime numbers, there is a boundation. That boundation is that if you are taking a non-prime number, it should cancel all of them. That is the foundation. Now, just one idea I'm giving you why this is wrong. Just one idea. So you have taken 12 outside because 12 is common to these two. If you have taken 12 outside, so can I say you have taken 4 and 3 outside? 4 and 3 is also 12, yes or not? Yes. Okay. Now 12 cancel these two. 12 does not cancel this, but 4 cancel this or not? 4 into 10. So that's why you have taken 4 outside. Because you have taken 12 outside, you have taken 12 outside, so you have taken 4 also. But that 4 you have not taken from, that 4 you have not taken it outside from 40. If you take anything outside, you have to take it outside from all the numbers. If you have taken 4 into 3, 12 outside, okay, 12 outside, so 12 into 2, 12 into 3. But this 4 also is there, na? Inside 12. That 4 you have not taken from 40. That's why the mistake is happening, which you are not able to see. Little bit idea have you got? Inside 12, there is 4 also, which is present inside 40, which you are not able to see or which you are not seeing. Okay, that's why the mistake is. All right. Now, next. (17) and 11, what is LCM? 17 and 11. The product is the LCM. Yes. Okay, so please remember these things. Now, LCM calculation. I think one or two questions you will see me doing the calculation of LCM. Even if the question is based on LCM, in that case, you will see me hardly that I have calculated the LCM. In the level 0 question, level 0 means difficulty level very easy. Only in those questions, we will do it by the formula where formula contains the value LCM. But we'll see that, okay? So LCM questions, most of the question we will solve it without even calculating LCM. Actually, LCM is the defining concept. If you see the solution in the books, any book, whatever you take, LCM, they will calculate. So what I'm saying is, we'll not calculate LCM that much, okay? We'll solve it without solving for LCM, without solving for HCF. So let's see those tricks. But for that, I've written something. Again, I will not apply this. Hardly I will apply this in the approach I will use. This is for the books. Okay, what books apply? This is this. If in a question we have more than one divisor, more than one means 2, 3, 4, 5. HCF of co-prime pair is always 1. No common factor, that means HCF is 1. So more than one divisor, that means 2, 2 divisor, 3 divisor, 4 divisor, 5 divisor, 6 divisor. If we have so many divisors and they are asking something, in that case, when we have so many divisors, we'll be confused that, okay, we have to take 6 divisor, 7 divisors. So don't be confused. Remove all the divisors, whether it is 5, 6 or 4 or 3. Remove all the divisors with just one single value, which is LCM. That LCM will be one single value. That one single value will take care of all the divisors simultaneously. What I'm saying is, please carefully understand this way. Suppose there is a question like number is divisible by 2, 3, 5, 7, 9. So find a number. I mean, options are there. Find a number divisible by 2, 3, 5, 7, 9 and least number. So now you are confused. Divisible by this also, this also, this also, this also, this also. So in that case, what I'm saying is, don't think so many numbers are there. Instead of them, think, remove them and write their LCM. That one single LCM value will take care of all. That is what I'm telling. Okay. So we will apply this wherever required. Otherwise not. Okay. In the starting, I am taking those questions in which you will not see any remainder which is given. I mean, when I say remainder, that means remainder is given, but it is 0. Please answer. Number is divisible by 2. So what is the remainder? Divisible by 2. Remainder is 0. Divisible by 3. Remainder is 0. Divisible by 5. Remainder is 0. Divisible by 7. Remainder is 0. Now, please carefully answer. So many divisors are there. What is their LCM? I don't want so many divisors. What is their LCM? What is their LCM? Anything common to all? Or anything common anywhere between the 4 numbers? No, nothing is common. If nothing is common, just multiply them. You will get your LCM. So LCM will be 7, 321, 242, 42, 5, 210. Okay, 210 is your LCM. So 210, replace them with 210. Now find the number 100 to 200. A number you have to find which is divisible by 210. So which number? Please see the options. Which number is divisible by 210? Only one option, which is 210. So this is what I was saying. In the books, you will see this approach, that they will calculate the LCM of this, then they will see, okay, which number is divisible by 210. Then they will solve it. So I have calculated LCM. But what I am saying is, don't calculate. Don't. Okay, for the first time, we have done LCM calculation. Now we will not. And particularly in the question where remainder is 0, we will never do it. Never. Now carefully see. I want to find a number divisible by 2. So I will try to find the option which is not divisible by 2. So which option is not divisible by 2? C option. So can I say this option is not right? Can I say or not? Carefully. We are learning a new approach by the solving by the options. When you solve it by the option, there are two approaches. Solving by options. There are two approaches in solving by options. Suppose, I'm saying, suppose B is the right answer. Suppose I'm saying. Suppose there is a question, B is the right answer. So what are the two approaches? One approach is find the 3 wrong answers. Carefully tell, if I am solving by the option, I find out that A option is wrong, C is wrong, D is wrong. So what is right? 3 options are wrong. So what is right? Automatically. B will become right automatically, yes or not? 3 options are wrong. Yes. So this is the first approach. Don't look for the right option. Look for the wrong option. Automatically, the last option will be the right one. This is the first approach. The second approach is try to find only the right option. Try to find the right option. Okay. So finding this, that means the right option, or finding the wrong option. These are the two approaches. Mostly, I will apply this. Mostly. Okay. So now, carefully see, please. C option removed. One option is removed. It is not right. Because it is not divisible by 2. Question saying divisible by 2. It is not. Now answer. Which option is not divisible by 3? Which option is not? B option. Okay. B option removed. Okay. Which option is not divisible by 5? Which option is not divisible by 5? You will say, sir, all are divisible. Okay. So all are divisible. So don't see 5 now. Go to 7. Which option is not divisible by 7? Is not 120. Okay. So 120 is not divisible by 7. Don't say, sir, it is divisible. Don't tell me this. I'm asking which is not divisible. The question has given conditions. I'm saying which option does not satisfy the condition. So this option is not satisfying condition of 2. This option is not satisfying condition of 3. This option is not satisfying condition of 7. So can I say 3 wrong options I've got? So automatically D option is correct. Yes or not? Yes. Okay. Question is done. Whether it is very, very small numbers like this, whether it is big numbers, we will try to use the same approach. Okay. Now you will be confused, sir. For big numbers, what we'll do, sir? Will we divide like this? Will we check like this? So don't worry about that. Let me take more questions just like this. All right. There is a certain number. That number represent number of student in the class. As per the question, what they are saying is, if I divide this number by 3 and solve it, I will get a whole number. Whole number means integer. If you will get a whole number, for example, by dividing, let's suppose you will get 12. What is the meaning of 12? 13, 14. What is the meaning? That when you solve a division, you will get an integer. Can I say divisible by 3? Yes or not? If you get a whole number, that means divisible by 3. Yes. Carefully see this. 12 by 3. You will get a whole number. 13 by 3. Will you get a whole number? Whole number means 0 to infinity. Will you get a whole number? No. Why you will not get a whole number? Because 13 is not divisible by 3. So when it is divisible, when you are taking a case in which divisible, 12 is divisible by 3, you will get an integer. And when you take a number which is not divisible, in that case, you will get a decimal. So my dear, here whole number means what? Whole number means divisible by 3. Whole number means 457. It gives a whole number. That means divisible by 4, divisible by 5 and 7. So 4 numbers they have given, divisible by 3, 4, 5 and 7. Number should be divisible by them. That is what they have given. If you want to calculate LCM, you can calculate. Okay. So how much is LCM for this? How much? Nothing is common. So 420. So 420 is correct. Okay. Now what I'm saying is LCM is 420. Okay. So 420 becomes the right option automatically. Okay. LCM is 420. Without LCM, how to do it? Okay. Without LCM, that means I want to solve it by the option. Please carefully answer. Which is the best number to take in the starting or to check? Which number? 7. 7. How come it is the best number to choose? 5. 5 is the best one. Okay. Out of the out of all these options, which options are not divisible by 5? Which options are not divisible by 5? A, B, C. Okay. Okay. A, B, C. They are not divisible by 5. So can they be the right option? Is it possible? Can they be the right option? No. So these are all wrong options. So can I say D is the right option? Carefully answer. Can I say D is the right option? Yes. Okay. So very easily, just with 5, we have got our answer. So my dear, I'm not saying this that in one step, 3 option will be removed. I'm not saying that. In this question, the options were like this, that they got easily removed. But not every time they will be easily removed. Please remember that. Okay. But yes, this was easy. Let's take one more question. All right. So please quickly try this question. All right, start please. All right. So see please, somebody has calculated 72 as the LCM. Now he is checking whichever calculation was easy, he has done it. So 720 is divisible by 72. So that is right. How are you thinking? 720. Okay, divisible by 72. 936 also is divisible by 72. Did you check? Did you check? 936, I'm telling you. 936 also, 864 also, 1008 also. They are also divisible by 72. Did you check? No. So whatever was easy, you checked it. Whatever was not easy, you didn't check. So things don't work like this. Okay. Now carefully see please. All the conditions of the question must be satisfied. All the conditions. Carefully answer. 3-digit number. Which option is not a 3-digit number? Fourth one. So it is 4-digit. So that's why it is removed. So rest of the option I will check. All right. Now checking by 3, 8, 9 is not difficult. All are divisible by 3 and 9. Check please. All of them are divisible by 3 and 9. Yes, no? Okay. Check please. All are divisible by 8. Check please. All are divisible by 8. Yes. So what I'm saying is, if you try to eliminate anything now, all the options are divisible by 3, divisible by 9, divisible by 8. So no option is eliminated. So which one will you say is the right answer now? Which one? Have we missed any condition? Have we? Yes, we have missed one condition, that is greatest. So greatest is out of the 3 option which satisfies all the condition, the greatest is 936. So that's why it is correct. So in such cases, what I will say is, you start with the greatest option. A option is greatest. So you start from there. 936 divisible by 3, divisible by 8, okay, divisible by 9. So this is correct. So whenever they ask greatest, you start with the greatest option and check. Then go to the next one, go to the next one. Okay, you will understand. Okay, we are just in the starting. Let's suppose we are taking this question. Okay, try please. Same approach. Don't calculate LCM. If remainder is not given, or say the language is like this, divisible by, that means remainder is 0. In that case, don't calculate LCM. Start please. Solve it by the options. Solve it by the options, always. Always cross check. Always cross check your answers before confidently saying this is the right answer. This is my final answer. Double 956. How come you are saying double 956? It is not divisible by 5. How come you are even saying that option? C option also not divisible by 5. So these two options I am not expecting. All right, two options have been removed. Okay, because they are not divisible by 5. Okay. The remaining two option I need to check. Now there are two approaches. Out of these two, that means B and D, either I try to find the right option out of these two, or I try to find the wrong option. Okay. If I try to find the wrong option, what I will do is, I will check both of them. Are they divisible by 3? Are they divisible by 3? Both of them. And 9. Yes, okay. So they are, sorry, not 9. They are divisible by 3. Are they divisible by 4? Yes. Are they divisible by 5? Yes. Are they divisible by 6? Yes. Divisible by 2, divisible by 3. Are they divisible by 8? Are they divisible by 8? Yes, no? Yes. Okay. Are they divisible by 7? Check, please. So, yes. So, both of them satisfy all the conditions given in the question about divisibility. So, how do I find the right option now? To find the right option, or let me say like this, all the options, B and D option, I'm saying, B and D options satisfy all the divisibilities. So what is the wrong option, I will say? Wrong option will be this. Why this is wrong? Because it is not nearest. It is not nearest. So both the options were satisfying all the conditions. I was not able to remove. So what did I check? The condition, other conditions like greatest, smallest, 3-digit, 4-digit, like that. So they are saying nearest to 10,000. So nearest to 10,000 is B option. B is correct. That is the first approach, in which I have tried to eliminate the wrong option. Now, how to find the right option? Out of B and D, please carefully answer. I want to pick one option. Okay, pick one option. Which is nearest? I will check that. Which one is nearest? B option. So B option I will check. It is nearest. 10080. Is it divisible by 3? Yes. Is it divisible by 4? Yes. Divisible by 5? Yes. Divisible by 6? Yes. Divisible by 7? Yes. 28, 28. Yes. Okay. Divisible by 8? Yes. So two options were remaining. I have taken the nearest option. The nearest option is satisfying all the conditions. So can I say it is the answer? Or should I check D option also? Careful answer. I have taken the nearest option. It satisfies all the condition. Should I check D option also now? Not required. So two ways are there. This one and this one. In this, I have checked the nearest condition later. In this, I have started with the nearest condition. Two approaches. Now, don't think too much whether I should apply this approach or this approach. The point is, try to check all the conditions as soon as possible, as fast as possible. Now, carefully watch. Anything doubtful? All the conditions must be satisfied. Okay, now next question. Until now, we are seeing very, very small numbers. How will you solve it? Okay, how will you solve it? Start, please. "24. What is the divisibility rule?" I want to check with 24. What is the divisibility rule? Yes, 8 and 3. So don't check with 24. Check with 8 and 3. For 30, what is the divisibility rule? What is the rule? 3 and 10. Okay, 3 and 10. So don't take 30, take 3 and 10. For 60, what is the rule? For 60, what is the rule? 12 and 5. 12 and 5. That means 5 and 12 means 4 and 3. So 12 and 5. Okay. So using these numbers, we will check 8, 3, 10, 5, 4, 3. Very quickly check this. Very quickly. All are divisible by 5. All are divisible by 10. All are divisible by 4. All are divisible by 8. Which option is right option? 32400. My dear, they're asking least. 1600. Is 1600 divisible by 3? How come you are saying 1600? I have no idea. Is it divisible by 3? 1600. One very basic check by 3 you are not able to do. Okay, 1600 is not right. So A option, 1600 is not divisible by 3. That's why removed. The rest of the option, that means B, C, D, if you check, B, C, D option, are they divisible by 3? Quick answer. All of them? Yes, no? Yes. Okay, they are divisible by 3. Are they divisible by 4? Yes. Are they divisible by 5? All of them? Yes. Are they divisible by 10? All of them? Yes. Are they divisible by 3, 4, 5, 10, 8? Are they divisible by 8? Quick check. Very quickly check. Yes. Okay. So my dear, 3 options are satisfying all the conditions. So what is the right option? The least one is the right option. So 3600 least is 3600. Just one more thing I will ask you. Is it perfect square? Is it a square of some number? Yes, it is. Square of 6 square is 36 and 10 square is 0000. So 60 square. So yes, it is correct answer. All right. So many questions, they will give you options like which satisfies all the divisibilities. So 3 options, you are not able to remove. 3 options satisfy everything, every single number they satisfy. So how you are able to get the right answer is by the condition, other condition like least perfect square. So please remember this. Sometimes very easily you will be able to remove 3 options, but sometimes only one option will be removed easily. So in that case, you have to be little bit patient, but yes, you will get the answer for sure. Now let's take one more question. This question was little bit easier because values were simple. We were checking by these values. But now the same question, values have been changed. That's why question difficulty has increased. The standard of the question is same. The language of the question is same. The values have changed. So now how will you solve it? Please start. Okay. So carefully answer. Will you divide these numbers by 21 and check? Would you divide by 21? Would you divide by 36? Or would you divide by 66? Would you divide? No. Okay, so don't divide by these numbers. Instead of them, okay, tell me, 21 we have not discussed, but still I'm asking. If I ask you what is the divisibility rule of 21, what will you say? 7 and 3. Okay, 36 we have discussed. 36, 9 and 4. 9 and 4. If I ask you divisibility rule of 66, what will you say? 11 and 6. Now don't say 6. For 6, you can say 2 and 3. So all these numbers will take. All are divisible by 2. Okay, 2 is done. All are divisible by 3. Check please. 3 and 9. All are divisible by 3 and 9. Yes. Okay. 3 and 9 done. Now check please. Divisible by 4. Which number is not divisible by 4? Which option? A option divisible. 44 divisible. 44 divisible. 34 not divisible. So if I check with 4, in that case, C option will come out as wrong. Okay. Next one. 4 is done. Now 7 and 11. 2 are remaining. Which one would you like to check? Why you will take 9 as 3 into 3? For 9, there is a rule, right? So why you will think 3 into 3? Okay, 7 and 11. Which one would you like to start with? All these are done. One option is removed. Out of these two, 7. Okay, if you want 7, apply the cutting method one by one. Check. If you want 11, then apply the divisibility rule of 11 and check. So please answer which option is not divisible by 11. Start with 11, please. Okay, B and D option you are saying. 2, 1, 3, 4, 4. Same value can be cancelled. Check please, divisible or not. B option 2, 1, 4, 3, 4. Same value can be cancelled, top and bottom. D option is 2, 3, 1, 4. Same value can be cancelled. Okay, 4 plus 1, 5, 3 plus 2, 5. Same value on the top, same value on the bottom. Yes. Sum equal to 5, sum equal to 5. Okay, net value 0. This is plus 5, this is minus 5. Net value 0. That means divisible. 3 plus 1, 4. 4 plus 2, 6. Answer please, divisible or not? B option. Is it divisible by 11? Plus 6 minus 4. No. Plus 6 minus 4 will give you plus 2. And that means plus 2 is not divisible by 11. 4 plus 3 is 7. And 2 plus 1 is 3. So plus 7 minus 3, will it give you divisibility? No. So I could have taken 7 also, but I don't know that 7 will be able to remove or not. I have taken 11 because I can apply the divisibility rule. Okay. So 11 is able to eliminate. Good thing for us is able to eliminate two options. So that means B and D option are not right. So what is the right option? Which one is right automatically now? A option is right. Okay. All right. Just carefully answer. With whatever knowledge you have right now, can you check this option is a square easily? Can you check? Yes, cutting method also you can apply. Remainder should come out as 0 if you are applying cutting method. Okay, is it easy to check whether this number is a square or not? I mean, all these numbers, is it easy to check? No. But is it required to check now? Three options have been eliminated. Is it required to check? Not required, because three options are eliminated. So automatically one option has to be correct. So that is correct. So don't ask me, sir, least square we have not checked, sir. My dear, not required. The other conditions are not satisfied by other options. So automatically A option is correct. This is how you have to do. All right. So until now, we have seen the questions in which the remainder was 0. Okay, remainder was 0 because language was divisible by this, divisible by this, divisible by this. Even if it is big numbers, I have not anywhere divided by big numbers. I have divided by numbers up to 11, not more than that. So we will not divide by big numbers. If there are big numbers, we will take their factors as per the divisibility rules we have discussed. If the numbers are small, we will take it directly. If numbers are big, we will think as per the divisibility rules. Okay, but what if remainders are given? For example, this question. Okay, carefully answer. Do we have to find a number which is divisible by 12 or divisible by 27 or divisible by 35? Do we have to find such number? Carefully read the question. No. Why no? Because remainder is non-zero. If remainder is non-zero, that means not divisible by 12, not divisible by 27 and 35. So will you solve by the same approach? Will it work? Or is it the right approach now? That you are checking divisible by 12. Okay, no. Divisible by 27. Okay, no. No, you will not check. Okay. So carefully see now. First understand, because this is the first question. First understand. Number is divided by 12. Number is divided by 27. Number is divided by 35. So how many divisions? 1, 2, and 3. 3 divisions are there. In all the 3 divisions, all the 3, they have given you a remainder of 6. All the 3. Remainder is 6. Here also remainder is 6. In all the 3 divisions, or in all the divisions, theoretically if I speak, if in all the divisions remainder is same, that is called as a structure. That structure or that model, we call it as LCM model 1. Carefully read, please. What is the statement of LCM model 1? How to identify? The question is this model. Okay, model means structure. So nothing. In these models, in these questions, remainder will be given. Okay, again, not one divisor. Many divisors will be there. 2, 3, 4, 5, 6. If all the divisors give you the same remainder, same remainder. If same remainder, LCM model 1. If not, it is not LCM model 1. Very simple to kind of see. Is this point clear? Please answer. LCM model 1. How to identify? Just look at the remainder. If it is same for all, that is model number 1. Okay. Now, for one case, only for one case, I will apply the formula and I will calculate the LCM also. For one case, the case is if they ask you the least value. If they ask anything else, not the least one, if they ask least value, I will do this. If they don't ask least value, although I have written, but I will not apply this. I will not apply. It is right. I'm not saying it is wrong. I'm saying I will not apply. But yes, in the books, you will see. In the books, they will apply this. I will not apply. Okay, so carefully see, please. To calculate least number, you just have to calculate LCM of divisor, add the remainder value, you will get your answer. So please remember this. I'm not saying it is the bad approach, but yes, LCM, just calculate LCM, add the remainder, you will get your answer. So what I'm saying is, please carefully see in the question. Okay, please read the question and carefully answer. Do we have the same remainder for all the three divisions? First question. Do we have same remainder? Yes. Okay, LCM model 1. Second question, are they asking least value or something else? Are they asking least? Okay, least value. So for least value, we will not think anything. For least value, least number, I will calculate LCM. LCM of all the divisors, that means 12, 35, 27. All the divisors, and I will add the remainder. This is your answer. Quick calculation, please. What is the LCM of these three numbers? Quick calculation. 12, 35, 27. Whatever is common, take it outside. 2184. All right. So carefully see how to calculate in this area only. Anything which is common, take it outside. So 3. 3 into 4 and 3 into 9. Anything common now? Please carefully answer. Anything common now? 4, 35 and 9. Anything common? No. Okay. So now we have to multiply. So 35 into 4 will be 140. 140 into 9 into 3. This is what we have to do. 140, sorry. Let me write here first. 3 into 4 into 5 into 9. This is your LCM plus remainder. Remainder is 6. I'm saying first for 35. First calculate this. So 35 into 4 will give you 140. Okay. 140 into 9 or 140 into 3. Any one calculation you will have to do. So what I'm doing is, let's 140 into 3. So I will get 420. 420 into 9 plus 6. Now 0, 9 to 18. 9 4 36, 37. 3780 plus 6. So 3786. Very quickly you will get 3786. LCM is 3780 plus remainder, you will get your answer. So C option will become correct. Okay. So just one thing you have to calculate right, that is LCM. So please don't do one mistake which you don't have to do. Only one calculation required, that is LCM. Please find the right value. Okay. Carefully see, please. Product, how you do it, that depends on you. Okay. But do it one by one. 35 into 9 is difficult. 35 into 4 is the easiest. Start with the easiest. Why do you want to know the process? Why the process? Okay. Okay, we have calculated LCM. Please answer, Rohit. What is the remainder of all these divisions? 3780 by 12, 3780 by 27, 3780 by 35. What is the remainder? How come 6? How come 6? I've taken LCM. I've taken just LCM. My dear, it is multiple of these three. What is the meaning of multiple? Remainder 0. Okay, remainder 0. Okay. Is the question saying remainder is 0? Is the question saying that remainder is 0? No. Question is saying remainder is 6. Okay. So now clear? This is the process. LCM will give you remainder 0. So LCM plus 6, LCM plus remainder will give you the required remainder. This is the process. Okay. Understood? Got an idea? Okay. Now, what I have said is, if by chance they ask you the least, don't think anything else. Just calculate LCM, add the remainder, you will get your answer. Okay. If least. Otherwise, we will go by the same approach, which is option elimination approach. Please carefully answer one thing. Will the option elimination approach works the same way in these questions if remainder is given? Will it work the same way? What do you think? No. Previously, we were checking, okay, divisible by 12, yes, no, no. Okay, removed. Divisible by 27, yes, no, no. Okay, removed. So we were checking divisible, but now remainder is given. So automatically remainder is given means not divisible. So how we will eliminate the option, that will change. Okay, so we'll see that. Let's take one more question. Okay, please try this question. Okay. All right. So question was this. Okay, least amount. Okay, that value will be a number, right? Okay, least amount. A person can have such that when he distribute or divide means the same thing, yes or not? If I distribute, that means I am dividing, yes or not? Okay, so distribute here means divide. Such that when he divides it into group of 16, that means divided by 16, divided by 18, divided by 20, divided by 25. Okay, so least amount when divided by 16, 18, 20, 25, he is always left with rupees 4. Left with, what is the meaning of this? Can I say it is remainder, yes or not? Okay, so what the question is saying is, there is a number, there is an amount. If you distribute it in 16 rupees, first person 16 rupees, second also, third also, fourth also. If you distribute this amount in 16 rupees, you will be left with 4 rupees in the last. If you distribute this amount in groups of 18 rupees, distribute it. Lastly, you will be left with 4 rupees. Similarly for 20 and 25 also. So number divided by 16, 18, 20 and 25, remainder is 4. Okay, and they are asking least value. So for least value, I will calculate LCM. So let's calculate LCM quickly. So 16, 18, 20 and 25. Okay, so carefully see please. 5 into 4, 5 into 5. Okay, now I'm taking 5. Okay, this is 4, 2. 2 into 2, 2 into 9 and 2 into 8. There is one more thing which you can do. Let me tell you that. Okay, suppose I've taken 5. So 5 into 4, 5 into 5. Now, repetition. How we have to check repetition? Carefully see please. This is 4. Do you think 4 is present somewhere else also? Do you think 4 is present somewhere else also? Carefully see. Don't see this. 4 is present somewhere else also? Yes or not? Yes, 4 is present inside 16, yes or not? 4 is present inside 16? Yes. So therefore repetition removed. If something is repeating because it is present at 2 places, remove it. 4 is present there, 4 is present inside this also. Remove it. Is this point clear? Please carefully, carefully answer. Repetition removed. It saves your time a little bit. Okay. Now next. Anything common now? 16 and 18, 2 is common. Okay. So 2 into 8 and 2 into 9. Anything common now? Carefully answer. Anything common now? Okay. No. 8, 9, 5. Nothing is common. 4 is already cancelled. Okay. So now 8, 5, 40. Let me write first. 2 into 5. 8 into 9 into 5. Okay. This will give you 40. This will give you 10. So 400 and 400 into 9 will be 3600. So LCM is 3600 plus the remainder, which is 4, will give you the answer as 360. All right. So least value, I will calculate LCM for sure. I will add the remainder value. I will get my answer. But yes, if anything other than least, I will not calculate LCM because LCM, directly with LCM, you will not get your answer. If directly I don't get the answer, I will not do it by the standard approach or by the traditional approach. I will solve it by the options. How to solve it by the option, I will tell you. Okay, just one idea I'm giving you. Try it after the class. Okay. Carefully answer something. Are they asking least value? Very careful answer. Are they asking you least? Are they asking you least? Okay, answer please. If I ask you find the least number or find the least 4-digit number, find the least 5-digit number, find the least 7-digit number, all are same questions. Are they same questions? So again asking you the same question. Are they asking least value without conditions? Least value, only least. Are they asking least? No. Okay, smallest means least, but what is this? One more condition is there. So no, they are not asking you least. It seems, but it is not. So will you apply the same formula, LCM plus remainder? Will you get your answer? No. Even if you apply, even if you apply, it will be very lengthy. I mean, even if you calculate LCM and try to do it, it will be very lengthy process. Okay. Let me tell you what you have to do. Okay. Does the question mean this? The number should be divisible by 38. Is it the meaning of the question? Divisible by 38, divisible by 22, divisible by 16. Is it the meaning? No. Because remainder is 15. Remainder is given as 15. Okay. I don't want remainder. If remainder is given, that is not the meaning. The meaning is not divisible by 38, divisible by 22. So why you are saying no is because remainder is given 15. Because of this you are saying no. Just tell me, because of this you are saying no, yes or not? Because remainder is there, that's why. Okay. So my dear, what you have to do is, in such cases, we will modify the options. Okay, remainder is there, na? You remove it. You want to eliminate from the options. So from where you will remove the remainder? You will remove it from the options. And these modified options you will check. Modified options. Okay. Now remainder is not there. Remainder was there, but I have removed it. I have changed the options. I have modified the option. From the modified option, I will get the answer. Okay. Just one thing I'm asking you. For example, again asking you, after doing this, what is the remainder? What will you say? What is the remainder now? 0. Remainder was 15. Now it is 0. Because I have removed it. Why did I remove it? Because remainder should be 0. Then I can check, okay, divisible by 38. Now, carefully answer. Remainder is 0. Again asking you. Yes. Okay, remainder is 0. So can I check this way now? Divisible by 38. Can I check this way now? Okay. So this is how we have to do it. For 38, you will take 2 and 19. For 22, you will take 2 and 11. And for 16, you will take 2, 4, 8, 16. Okay. For 16, the rule is last 4 place. 2 power 4, last 4 place. Okay. I'm just trying to tell you something. Please carefully answer. This will give you, this subtraction will give you odd number or even number. Odd or even. Odd number, even number. Odd number. Can odd number be divisible by 2? Check please. Is it divisible by 2? Is it possible? No. Option removed. Okay. If I subtract this, I will get 1,000,000. 2,000,000. Is it divisible by 4? 2? Yes. Divisible by 8? Yes. Divisible by 16? Yes. Okay. Is it divisible by 11? Please quickly check this. Is it divisible by 11? Quick check. Very quickly. Is it divisible by 11? Yes, no? No. Okay. Therefore, this is not divisible by 11. Therefore, B option is removed. Like this, you have to check. Okay. So I will start with this question again tomorrow. Please try to do it the same way I have done it. So please remember this, because remainder is non-zero. That's why we cannot check directly. First, you will have to subtract the remainder. Okay, subtract the remainder. Modify the option. With the modified option, you will have to check. Understood, all of you? So try to do it after the class. And tomorrow you will start with telling me what is the right answer. D option. Okay. So what is the right answer? Delete. C. Okay. All right. So we'll start with this question tomorrow. Okay. And this is the first model. The other models we'll discuss after this. Okay. With other models, what we have to see. Yes, I will share the notes. So with other models, what different things, how to identify the models, what is model number 2, that we'll see tomorrow. Okay. Thank you.